All right, so now we're going to solve each logarithmic equation. We want to be sure and reject any values that are not within the domain of the original expression. So you just want to be careful. So for example, I'm not requiring you to list the domain, but like the domain on 74, um, my values need to be greater than 3. Okay, so if I get any answers that are less than 3, there would be a problem because you can't evaluate logs at 0 or negative numbers. So just something you'll want to double check as you get your answers. So the little trick we do here, it's kind of like the one-to-one property but backwards. So what we're going to do is we're going to introduce bases and create these to be exponents. So I'm going to put a 4 here. I'm going to put a 4 here. Okay. And so the property here is if you have 4 raised to a power of log base 4, and then whatever's being evaluated, that's what it actually simplifies down into. So this is going to simplify to an x minus 3 equals, and then 4 to the third power is 64. And then we go ahead and add 3 to both sides. And so I get x equals 67. And that's my answer. And there's no issues with 67 being my answer. Okay. The next one, we're going to kind of do the same deal, but I have to clean it up a little bit before I get started. So what I'm going to have to do here is subtract 3 from both sides. Now I get 4 times the natural log of x equals 12. And then I'm going to divide both sides by 4. And so now I have natural log of x equals 3. And then the base of natural log is e. So I'm going to introduce a base e on both sides. Okay. And so it just, the left side just simplifies into x, and then the right side is e to the power of 3, and we'll just leave it like that. We'll just leave it like that as an exact answer. All right. All right, so these next two are actually going to require condensing. Ugh. All right, so right here on the left side, we're going to bring these two logs together. And when you do so, you multiply the two parts that are being evaluated together. So this is going to become log base 4. And when you multiply it together, it's going to become x squared plus 3x. And then this all equals 1. And then just like, so that was like the only extra step compared to what we saw up above. So now you go ahead and insert a base 4 on both sides. The left side simplifies into the x squared plus 3x, and then it equals 4 to the 1 power, which is just 4. So if you, once you get to this point, you'll want to recognize that you have a quadratic equation, so you need to set equal to 0 and factor. So let's see, we get x squared plus 3x minus 4 equals 0. And let's see, this factors into x minus or plus 4, and then x minus 1, or vice versa. It doesn't matter what order you put them in. Okay. And so my my possible solution set is -4 and +1. Now you'll want to take a close look at this, and you'll notice that -4 cannot work. So you want to make sure and cross that out so you get full credit. Okay. If you plug in -4, you'll get some issues. You can't, remember, you can only evaluate logs at positive numbers, not even 0. They have to be positive. Not that you can't have negative answers. You can, but in this case, that's not going to work for you. Plug in 1, there's not any issues if you plug in a 1. It's within the domain of both of them. It has to be both, okay? Not just one, but both. All right, so now 77 is kind of similar, except that you're going to do the quotient of what's being evaluated here. So you're going to get log base 3 of x minus 1 all over x plus 2. And this all equals 2. So what I'm going to do is I'm going to insert a base of 3 on both sides. Okay. And so the left side simplifies to what's being evaluated. So x minus 1 over x plus 2 equals 3 squared is going to be a 9. So you can go ahead and put the 9 there. So what you want to do here is, I'm assuming we don't like fractions, so we're going to multiply by x plus 2 on both sides. And what that will do is eliminate the fraction on the left side. So we can cancel that out here. So now we're left with x minus 1 equals, I'll go ahead and distribute the 9 now. So I'm going to get 9x plus 18. And now we want to go ahead and solve this. So let's subtract x from both sides. We get negative 1 equals 8x plus 18. Then we go ahead and subtract 18 from both sides. And so we get negative 19 equals 8x. And then we'll divide by 8 on both sides. So our potential solution that we're coming up with is negative 19 over 8. Okay? But that poses a problem. That actually is not going to work. Because if you plug it in, you're gonna plug in a negative and then subtract 1 from it. You're gonna try to evaluate a log as negative value, which is not possible. So that doesn't work, and so in this case we're gonna have no solution. No solution or empty set, however you want to look at that, same thing. Okay, so I have one more down below here. Kind of similar to what we got done doing up here. We're just going to have one extra little property here. So we do want to go ahead and condense this. So you're going to multiply the 5 by the x plus 2. So we're going to get log base 6 of 5x plus 10 equals log base 6 of 4x plus 1. And what we have here is we have another one of those one-to-one properties. We have log of 6 on both sides. And so really, we're just kind of focused on, well, what would make the two parts being evaluated the same, because the log base 6s are the same. So what we can do here is basically cancel out the log base 6s and just focus on the internal part of each one that's being evaluated. So we're going to go ahead and have 5x plus 10 equals 4x plus 4, and we'll go ahead and solve this. So I'm going to subtract 4x, subtract 4x. Okay, so we get x equal, or oops, don't want to forget about the plus 10. Plus 10 equals 4. And then we'll go ahead and subtract 10. Subtract 10. And so we get x equals negative 6. So we're actually getting the same problem we had up above. We're getting a bad answer. If you plug it in, the problem is you would evaluate this at negative 4, which is not good. So if it causes a problem anywhere, it doesn't work. Okay, so that one's going to be a no solution also. All right.